I have named the faces as 1 and 2. So 1 is black, and these are the 3 faces which are adjacent to this charge. One face at the top, and this face which is on the right side, and this third face which is at the back. So these are type 1 faces. Okay, flux through type 1 faces will be 0. Flux through type 1 faces will be 0, and flux through type 2 faces, which are bottom, left side face and the front face, will share equal flux. Okay, so we can say as flux through type 1 faces 0, flux through type 2 will be 1/3 of flux of cube. So flux through 2 is nothing but q by 24 epsilon naught. Okay, so these two questions can be given in various forms. Let's say there is a charge which is placed a by 2 above the center of a square sheet. So the flux through square is nothing but q by epsilon naught, q by 6 epsilon naught. And if a charge is placed at a distance a directly above its corner, let's say q dash, so flux through square due to q dash is q dash by 24 epsilon naught. So these are the two questions which they generally ask or modify from these examples. Okay. In the next question, there is a charge q. We have to find the charge enclosed by the cube if field is given by alpha x square. It is a cube of side length a. Okay. So field is alpha x square I cap. As the field is along this direction, we can say no flux will pass through any other phase except these two phases. Okay, so these two phases will have flux. This is called as phase 1, this is called as phase 2. All other phases will not have any flux through them, as the field is parallel to all other phases. So flux through phase 1. To get that, E at phase 1 into area with a minus sign, because the flux or the field lines are entering. Okay, so E at phase 1, as x is 0, field will be 0, alpha into 0 square minus into area is a square, so it will be 0. Flux through phase 2 is plus E at 2. Why this plus? Because the field lines are entering, leaving the cube. So it will be E at 2 into area. Field at 2 is alpha into a square. As the value of x at this phase is nothing but a, we plug it here, so we will get alpha into a square. That is the field at this phase. And area of this is again a square, so we get alpha a to the power 4. So the total flux, which is summation of these flux phi 1 and phi 2, so we can say it is nothing but alpha a to the power 4. Hence q enclosed is phi total by into epsilon naught. So that will be alpha a to the power 4 epsilon naught is the net flux or net charge enclosed by the cube. Okay, in the next example we have to find the flux through the sphere. Okay, let's case 1. Case 1 is field is along this direction, perpendicular to the circular cross section. Let's say this is case 1. So phi in case 1 will be E into pi r square. Again the word is pi r square, because in uniform electric field we can take the projection. Okay, we can take the projection as we solved in the previous questions also. Okay, and if the field is like this, we can say the field is like this. Let's say in case 2, E2, that will be E into pi r square by 2. As the cross section formed when the field is along this direction will be a semicircle. So we can take the area of a semicircle and the net flux passing. Okay, but whenever you are asked net flux, it will be 0 if E is uniform. Okay, if field is uniform, then the net flux must be 0, as equal number of field lines will enter and leave the object.